Good morning or afternoon, class. I wanted to move forward in the unit for ecosystems. This is the third section of the unit. We've conquered the interactions between organisms, which is the first part, then the flow of energy, which is the second part. Now we're into things that influence population size. So this is super easy. There's only two different categories. There's density dependent and density independent. So dependent means it depends on a factor. When we do an experiment, we have our independent variable and our dependent variable. Our independent variable is the cause. The dependent variable is the effect. So the dependent variable is occurring because of the independent variable. When we run the test, at least we're testing to see if there is that relationship. So this is dependent on density. The more dense the population, the more this thing will have an effect. Density independent doesn't matter if it's highly dense or not, if there's a crowd or if the individuals are spread out. So let me walk you through both of these. Density dependent. Most of them are biotic. Biotic means it's living. Abiotic means it's not living. Density independent is mostly abiotic. So these are mostly living factors for density dependent. Things like predators and prey. The more prey you have, well, that's going to increase the population. The more predators you have, that's going to decrease the population. So the number of these, and these are living things, predator and prey, they're living biotic factors. The more or less of these, the more it's going to affect our population size. So it's density dependent. Also, the plants that are supplying the first trophic level for food that works its way up through the ecosystem, their numbers are going to be a density dependent factor. And then parasites that can cause disease or illness or even eventually death. These are factors that affect a population. So let me give you a hard example. Let's think of like a herd of buffalo. The herd of buffalo, the bigger the herd, the more parasites that they're sharing with one another, the less food there's going to be because there's many more of them. There may be more predators that are going to affect them, and these are factors that are going to affect the size of the herd. As the herd gets bigger, these factors are going to start to grow as well and work against the growth of the herd. For humans, biotic factors, we don't really have predators for humans. But the bigger our population, the more strain we have on our ecosystem, and the higher chance that we're going to pass parasites from one another and crowding. The struggle for prey and plants for food sources gets bigger. So, for example, our fellow Americans that live in dense cities, if they didn't have a supply of food coming in from the countryside, they would not be able to feed the whole population, but we truck in food. There's too much density in the cities for them to produce their own food, so it has to be brought in. Density independent. It's mostly abiotic, non-living things, as I erase the I off of ibiotic. Abiotic. Examples of these non-living things. Pardon me, the cat is Miller. Miller, baby. Alright, she's just going to hang out for a little bit. So, the examples of abiotics are non-living things like water, light, temperature, soil. This is just a short list. There's many more. If there was not enough water to go around, then that can cause the population to drop, and water is not living. Light available for keeping the plants going. Like, for example, the Earth has a tilt on the axis, and we tilt one way or another with our seasons. So as the light becomes less, we go into winter, and that can affect the next one, which is temperature. The temperature is not right. That can affect populations. Soil. When I mean soil, I mean the nutrients in the soil. There's not enough nitrogen, potassium, phosphorus, calcium, and other minerals that are needed for plant growth. These are abiotic. And it doesn't matter if the crowds are really large or really small, these things will still affect individuals. So crowds don't really have as much effect. Abiotic density independent factors, another good way of thinking of this is natural disasters like a major flood or hurricane. It doesn't matter if you're crowded in a city or if you are out in the middle of nowhere, you're still going to be affected by a natural disaster. Now, I do have it mostly, there is exceptions to these rules, but most of the abiotic factors are density dependent. Most abiotic factors are density independent. Doesn't matter if you're crowded or not. So why does this matter? Well, these things help determine where carrying capacity is on the line, that red line. Is it going to be higher or is it going to be lower? And when it comes to density dependent factors, as the population gets bigger and bigger and bigger, this line may start to go down, like drop. The red line goes down because now they're competing. It's competition for space and resources. As density independent factors may change, less water, less light, temperature change in the worst way, less nutrients in the soil, the carrying capacity may also drop or rise if conditions get better. So these are factors that influence carrying capacity on that line. I hope this helps explain the difference between density dependent and density independent factors. The next section will be posted shortly, and this is the halfway point of the notes on ecosystems. See you later.